Hello, everyone. Welcome back to MP Coding. Today, we will discuss print levels or log levels. This is a simple example, but when we develop kernel modules, these kernel messages are very useful. So, today let's talk about that. For reference, you can use either the Linux Device Drivers 3rd edition book or this web link that I will add to the description. Now, let's start coding. As before, I have connected my Raspberry Pi board's LDD folder over SSH to my host machine in VS Code. Inside this first kernel module folder, we will create a new folder and copy the files from our previous Hello kernel module. If you want to do this without VS Code, use the shell command palette like this. To copy, type cp-r followed by the directory to copy. Here, I am in the first kernel module folder, so I will specify the 01_hello folder. Then add a space in the destination folder. Here, I want to create a new folder and paste the files there. Just give the new name to the folder. I will give 02 log levels, then hit enter. Navigate into the new folder. You can see the files are copied. Now, let's rename this hello.c file. Type mv followed by the file we want to rename, then a space and the new file name. Here, I give loglevels.c, then hit enter. You can see here file name has been changed. We need to update the object file name in the make file as well. For that, type nano or any other editor, followed by the file name. Edit the name here to log_levels.o. Save and exit. This is how it is done when using only the terminal. But with SSH, we are connected to VS Code, so it is easy. Just copy the folder and paste it, then rename, just like that. Now that everything is set up, open the source file. First, update the module description to our log levels check kernel module. Now, open the reference page. Here, we see the log message levels table. This shows the name for each level, along with the string number attached to specific message levels. I will show you how we can use this number. Here, we see the levels: emergency, alert, error, warning, info, debug. This is how we use them in our code with printk. But these alias functions can be used directly without specifying the name macro to printk. Now, let's see these in action. Now, in the init function, edit the printk statement. Use the kern_info macro and change hello to log_levels. Next, let's add other levels as well. For that, copy this one and paste multiple times. For alert, change the macro to alert. And then change message to this is an alert. Change for the other levels as well. We always use this pattern for kernel messages, module name :message. If we look at the kernel message buffer, other modules follow this pattern. It is good practice. But we need to type the module name each time. To avoid that, add this name to variable. Static const char pointer module_name equals to log_levels. Pass this variable to the printk message like this. This is how it done in correct way. In the exit function, use these alias functions, like before. Add recognizable messages as well. Alright, let's build the module. Type make and press enter. The build completes without errors. Now, load the module. Before loading, start watching the dmesg output. Type dmesg-w. load the module, sudo insmod loglevels.ko. You can see the messages printed. The alert is highlighted, and the error appears in red, and other messages as well. Let's remove the module. Sudo rm mod log levels. You can see the messages printed as expected. These print statements with macros and the alias functions are both valid. They give the same result. If we look the pr_info function, it is just helper that simplify the macros. So nothing new in the alias functions. If we want messages from a specific log level only, add the level flag to dmesg. For example, type dmesg --level equals 0. This shows only level 0 messages. For multiple levels, separate the numbers with commas. For example, type dmesg --level equals 3,4. This shows only levels 3 and 4 messages. That's all for log levels. In addition, we will cover how to set parameters for the module. This is outside the main scope, but we will review it quickly. Here, I have added some code. Let me explain it. At the top, these lines. They declare static variables, an integer, a boolean, and a char pointer. Here, initialize the integer array. To declare module parameters, use this function. This function takes the parameter name, type, and permissions. Search for details on permissions if needed, but we will not go into depth here. We cover that later in the series. This is how we set the parameter description. In array parameter declaration, need to use this array declaration function, and we need to pass the reference to the array size parameter as well. Here I have just add prints for these parameters in the kernel messages. Before build, comment out the previous print statements. Build the module, and then load the module again. Here, you can see the parameter values printed to the console. If we check the module info now, we see the parameter descriptions added to the module's metadata as well. This is how to set module parameters. That's it for today's video. In this video, we explored kernel log levels using printk macros and alias functions. We saw how to print messages at different severity levels and filter them with dmesg options. We also covered module parameters briefly, declaring, setting descriptions, and printing their values on load. These tools help debug and configure kernel modules effectively. All the materials and shell commands used in this video are uploaded to GitHub. Check the repository files for reference. Thank you for watching. See you in the next video.